Hello, my name is Jędrzej Malinowski, and at the beginning I would like to welcome all our attendees on our annual seminar. It's great to have all of you on this meeting. Today I will have a big pleasure to discuss with Thomas Strabo about the hardening of stainless steel and titanium alloys. Hello Thomas, good to see you.
Yes, good to see you.
Today we have the opportunity to visit your plant in Germany and have a discussion about the Expanite processes.
Yeah, good to have you here. So we're here in the plant in the middle of Germany, the middle of the automotive industry, and we have placed our central plant here because we see a lot of business around here. We have several other plants, but today I think we will move around this facility and I will show you some of the furnaces. I will take you through the technology, both hardening and maybe also some software technology. And we will have a closer look at the furnaces later on. There's a little bit of background noise here, so I think we will perhaps go to the office and have a dialogue about the technology.
Okay, so let's give Thomas some time to go back to the office. Thomas, if I see well, you are in the office now, so let's start our discussion. Could you tell us more about the Expanite as a company and your processes, of course?
So Expanite is a Danish founding company. We were founded 10 years ago, and it's based on a lot of research within stainless steel hardening. And I am one of the co-founders, and my two other co-founders, they are today working at the university still. So for the last 10 years, we have been hardening stainless steel parts for customers out of our different facilities. We have a headquarter in Denmark, just north of Copenhagen. And then we have a big center here in Frickenhausen, near Stuttgart. And then we have various places also in the US, Korea, and soon also in India. And from there we are offering the technology within hardening of stainless steel and titanium.
So, tell me why you called your company and processes Expanite.
Yeah, so this is a funny story about that. What we really do is that we put nitrogen and carbon into the surface of stainless steel. Imagine that stainless steel is made up of atoms, and those atoms can be in different structures, ferritic, martensitic, and austenitic. And what we do at Expanite, we are diffusing nitrogen and carbon atoms into the surface of the material. And that way, the surface will expand a little bit and form what we call expanded austenite. And that's why the Expanite comes from.
Okay, Thomas, so please let us know what the processes brings to customer.
The good thing about this process is that you can apply it in multiple ways. Originally, the vision was to make a process that was clean, so without any post-treatments. We had a vision of making a process that could be installed at customer sites. So we had this vision about installing furnaces directly in the production line at customer sites. And we had a wish about making a process that we could tailor really to the application. And in order to do that, we have to base the processes on thermodynamics. And thermodynamics in this case would be gases. So we had a vision about making a gas process that would be clean, that could be installed on site in furnaces. To answer what we really do, I told you that we introduce nitrogen and carbon in the surface of the steel, and what does it bring? The benefit we really give customers is a lifetime increase. So we are making stainless steel very hard, and by that we are increasing the gulling resistance, we are increasing the wear resistance, and you will see an extension of the lifetime. Furthermore, and further to this, we are benefiting from the presence of nitrogen, because nitrogen is a very good thing when you are operating in seawater applications. And seawater applications demands corrosion resistance, and the nitrogen really improves that. So by introducing that, we can improve the corrosion performance in certain environments. But it's not only that. Around the technology and the benefits like galling and wear resistance and so on, also comes the simplified logistics. Imagine we have customers in the US that for the last 10 years were shipping parts to Europe, and now they have their own furnace and from day to day can produce parts. So it simplifies logistics, and we actually were the first ones who made this kind of technology available in Asia and in the US. So besides this clean technology we have and the no need for post-treatment and so on, we also have a vision about being the fastest in this industry. And we can do that because our processes are very short compared to our competitors. So we can have day-to-day delivery on surface hardening of stainless steel, which is quite outstanding in this industry. We are working right now quite structured with certain customers about replacing hard chrome plating, which is a surface coating that will be banded in a few years from now. So there's a high attention, a high focus on replacing this technology. And we have certain very good cases where we are successfully replacing this technology. And with this, and the third and last point I will make is the environmental part of Expedite. We don't use acids, we don't use fluorides and so on. We use standard gases to achieve the hardness, to achieve the corrosion performance. So from an environmental aspect, we are also quite competitive.
So my next question is why your processes are so unique?
First of all, it's the stainless steel character. So you have steel, you have chromium in it, and you have a passive chromium oxide layer. And to be able to harden stainless steel, you need to bypass this oxide layer to introduce nitrogen and carbon. And removing this oxide layer can be done in various methods. By sputtering in plasmas, it can be done by acids, fluorides, and it can be done by a gas process, as Expedite is. But once you have passed this challenge, you are a good way down the line to harden the stainless steel. The second challenge is really the low temperature, because it's quite tempting and quite easy to remove the oxide layer if you just increase the temperature. But you need to be at a low temperature, because if you are increasing the temperature, the chromium will start moving in the system and reacting with the nitrogen and carbon and form what we call nitrides and carbides. And by that, you will lose the corrosion performance. So it's absolutely important that you keep the temperature very low, so it's only the interstitials like nitrogen and carbon that are allowed to diffuse into the material. The third challenge, or maybe it's not a challenge, but it's a benefit if you accomplish it, that is to make the process a gaseous process. By gaseous process, we mean introducing gases in a furnace, controlled flow, controlled temperatures, and things are controlled by thermodynamics. So you can expect the same results if you introduce the same gases at the same temperatures. And that gives a good repeatability. It gives a good, let's say, ways to tailor things. You can really play around with the gases and tailor the characteristics and the outcome of the parts afterwards. The fourth challenge is a challenge that is, for someone, let's say, not quite obvious. For us, it's very important. If we look at a stainless steel part, we look at the surface. The surface is what is important for us. We are making expanded austenite, so we would like the surface to be austenitic. But if you have a component and it has been through a machining shop, you don't have austenite in the surface. You have different things like ferritic, you have delta ferrite, you have martensite, and all those things you need to, let's say, remove to get a nice ground for our process. So the cold worked surfaces is really a big issue, and typically it's more important than the alloy itself.
Well, my following question is how these processes are realized in practice.
So, over the last 10 years we have matured our processes. And to begin with, I was a scientist, and I was playing with the recipes and playing with the gases and so on. And today we have really standard recipes that are targeted different applications with a known outcome. And those recipes, or products we call them today, they are really grouped into our 4 different processes that we have. The first one we have is the Expedite low T process, which is really just a nitrocarburizing process at low temperatures. It can be applied to let's say, some martensitic grades, some duplex grades, and so on. And then we have a Expedite high T process, which is a high temperature process, Temperatures are up around 1150 degrees C or so, and we're introducing nitrogen also here, only nitrogen, and we are quenching very fast. And if you combine those two processes, you get what we call super expedite. So super expedite is really a combination of the high temperature process followed by the low temperature process. And it brings me back to what I told you about before, that we would very much like to get rid of all those cold work surfaces, and we achieve that in the high temperature process. And please don't exchange it, let's say it's not an annealing, because annealing would just make things very soft. We are compensating for the hardness loss by introducing nitrogen. So we are gaining some of the lost hardness in the surface by the nitrogen content from the high T process. So combining those two processes, we get the super expedite, and this is really the most offered process. I would say 80% of what we do is super expedite, and it's used for many things. The last process we have is a process dedicated for titanium alloys. And titanium alloys is a little bit different from stainless steel. There's a big part of it where you need to consider the heat treatment of the core material. So what we do with expedite hard CI, we call it, we are also diffusing an interstitial oxygen actually, and we are forming a diffusion zone like we do on the stainless steel, and we make it medium hard as well. Attached to this process we have a secondary diffusion process, so you can actually achieve metallic appearance of your components. So this is really the four different spaces we are in: a low temperature process, a high temperature process, a combination of those two, and then finally a process for hardening of titanium.
Thomas, in such a way, if I would like to buy expedite process, how can I do this?
It's a good question, and it has two answers. And before answering, I need to go just a little bit back in time. We are going back in time because originally our vision was to make a process that we would just sell to on-site customers, and I could sit laid back home and look at the furnaces. We soon realized that we need actually two strategies. We need a strategy where we are selling furnaces to customers, but we also need heat treatment shops to do workshop handling. So you could say the technology focus in expedite has changed a little bit. 5-10 years ago, it was about developing technologies, developing the hardening recipes and so on. Today, it's also about facilitating equipment at on-site installations. And you should think about that expedite processes are protected by IP. So the recipes are secret, you could say, and they will not be obvious for the end customer. So the equipment needs to somehow, let's say, keep the recipe hidden from the users and not from expedite. So the equipment needs to be without any display. It should be a really plug-and-play solution where you simply have a few buttons, but all the recipe handling will be done by expedite. So if you should buy expedite today, you could do two things. You could go into a heat treatment shop with your parts, we will heat treat them, harden them, and you will have them back quite fast. But if you're a big customer with a lot of material, you could buy a full installation. And a full installation would typically be a combination of high temperature furnace and a low temperature furnace, because you would probably like to do super expedite. You will not have any display on the furnaces. You will interact with the furnace from a browser, from your iPhone or whatever. And the thing is that when you start the furnace, the recipe will be downloaded from expedite server to the furnace and be executed at the furnace. When the furnace is completed, the recipe will disappear from the furnace. So we consider the furnaces as resources, and it's one of the reasons and one of the software drivers for us that we needed to protect the IP on the furnaces for the on-site solutions.
Thomas, please tell us more. What application are these processes suitable for?
In the early days, we thought, well, this will work great on jewelry. It will work great on a scratch-resistant knife or scratch-resistant home appliance. But this is really not where we do it today the most. It's industrial products, so it's really screws, it's valves, it's pumps, it's fittings, it's a little bit consumer products. So we have some watch cases, we have some jewelry, but it's categorized in, let's say, food and beverage as the biggest one. We have automotive as the second biggest one. We have consumer products, and we have some pumps and valves. And you could say this is the main groups, and then we have some niches. But I would say food and beverage is really the biggest one today. And a few examples of applications would be, let's say, screws for transporting food in pipes and so on. I hope I can show you some on the floor in just a few seconds from now. It could be things for pumps that would be fuel injectors for automotive. You think about a vehicle has an engine, and an engine consists of a lot of different things. And some are supplying the injectors, some are supplying the gearbox and so on. And Expedite is typically delivering parts into, let's say, the things that are doing a lot of repeatable movement. So that would be fuel injections. So what we see is a lot of armatures. We need some magnetic parameters, characteristics as well, which Super Expedite in this case will give it. And you will see that ferritic is a typical alloy used in this business. And I think we have some parts on the floor I can show you.
Okay, so don't waste the time. We can go to have a look on some parts. In such a case, we need to give Thomas a short time to go back to the workshop. Thomas, are you there yet?
Yeah, so here we are on the floor, and we have some parts, and we see the armatures I mentioned earlier on going into a fuel injector. So this is really what they look like when they come out of the furnace. And they go into the furnace like this, which is a benefit, of course. So the gas really gets in everywhere, so we don't have to think about how things are placed in the furnace. They can just go in. We have other applications. This is a food application, some kind of bushing. We have some other applications that you will recognize as well. Some 3mm screws. I think this is it's not food and beverage, it's some kind of industrial product. Then we have over here another product. It's difficult for me to say what it is. It's some kind of an axle, stainless steel 316, used for food applications at least. We have a counterpart here that goes together with that one. So they will go into each other, and you will need to be sure that they won't gouge. So we have this anti-gouging function. We have a bigger part here. Again, not really sure what it is, but for sure some kind of food application.
Thomas, thank you very much for the interesting conversation and for the opportunity to visit your plant and see how it really looks.
Thank you, it was a pleasure having you. And to all of you out there, please give us your parts, we will take care of it, and we will make it very hard and very resistant. Thank you.
Dear guest, I hope our discussion was interesting for you and at least brought some answer for your question related to the process of the hardening of the stainless steel and titanium alloys. In case of further question, please do not hesitate to contact Thomas or me. At the end, I would like to thank you for your attendance and see you on the next lecture.